Okay, so this is passage 5. And on the right hand side we see we've got a diagram. We have a table and it looks pretty simple. It's only got 4 values. We've got 2 graphs that have the same kind of shape. That's good. And they look very simple. They've only got 3 lines in them each. So I'm not going to bother reading anything until I have to. So I'm just going to start with the questions and read whatever I have to read. So question 24, according to figure 3, so that's going to be step 1, will be find figure 3, and I don't have a pen. Always good if you have a pen. Right, so find figure 3 is number 1. If D equals 7.5 meters and W equals 100, the greatest change in T occurs where theta increases from. So if D equals, that'll be 2, and 3, we need to find W equals N, the greatest change in T. That'll be 4, when theta is what? Well, there's a lot of information here, so I might actually have to read the thing, but let me just see what figure 3 shows me, and then I'll see what I have to read. Figure 3 doesn't give me any. Okay, I've got 0.75, so this is D. And W equals 100N. Okay, I don't know what that means. So let me find a description of figure 3. So I'm going to come over to here and it starts talking about the tables here. Table 1 lists F, which is what? Is force F, the braking force. So table 1 lists that in newtons for stainless steel. Figure 2 contains graphs of T. I'm going to look up here. T, I'm thinking it's tension, but and will each affect the tension T. Okay, so figure 2 graphs of the tension in newtons versus theta. Theta is up here, is the angle between the cable, all right, and various W and N, and W is the sine's weight. Okay, I ended up having to read it, but fair enough. So now I know what all the different things are, and we were looking at figure 3, and figure 3 contains graphs of the tension versus the angle for various diameters where W equals 100, where the weight equals 100. Okay, so we don't have to worry about this step 3, the W equals 100, because that's what this graph is. So 1 is find figure 3, 2, we found a 0.75 and it's the white triangle. So this is the top line is the triangles. I'll increase that so you can see that it is actually the triangle. Now we have to find the greatest change in the tension, which is up the sides, when theta increases. Alright, so we have theta degrees along the bottom and you see it's increasing. So we're just trying to find in this top line the biggest change. Where is the biggest change that happens? And that, I think it's pretty easy to see. It happens here. This goes down sharply and then it kind of levels off and levels off and levels off. So the biggest change happens from this, which is like almost 600 to about 350. So that's between 10 and 20, and that is F. Number 25, based on figure 2, so that's going to be my first thing, is to find figure 2. This is going to be number 1, find figure 2 for D equals 50, and any given theta, what is the order of the sine weights from the weight that produces the greatest cable tension to the weight that produces the least cable tension? Alright, I'm probably going to have to read a wee bit about figure 2 again, because let me see. So I'm going over to the right hand side. I need figure 2. So that's this one here. What does it say about figure 2? Let me just see. Figure 2, this information is here. it contains graphs of the tension here versus theta, which is the angle, I remember that bit, for various, I scribbled all over that, but it does say for various weights. Okay, so various weights, so that means weights in N, so the key has the weight where D equals 50. All right, so D equals 50, we know that. Of any given angle, what is the order of sine weights from the weight that produces the greatest cable tension to the least? All right, so we know this here is the weights, and the white circle is 100, the black square is 200, and the white triangle weighs 300. So which one, if this is tension, and it says it wants it from the greatest cable, so it wants it from the highest value, the greatest tension, to the lowest. So what's the order? So the greatest value is the triangle, so it's 300N. The next one that produces the next highest tension, because again tension runs up here, so the next highest one is the black square, and then the least one is so the black square is 200 and the white circle is 100, so it goes 300, 200, 100, and that's D. Number 26, consider the data in figure 3. So that'll be step 1. D equals 0.25 and D equals 0.5. For each value of D, what value of theta results in T100? All right, so 2, I need to find 0.25. 3, I've got to work out what 0.5 is. For each value of D, for both of them, what's the value of theta that is 100? All right, so that's number 4. What value of theta would give me T equals 100N? So number 1, I'm going to find figure 3. And then we have the D's here. And I'm looking for one that's 0.25, so that's the white circle. And I'm also looking for the one, step 3 is the one that's 0.5, and that's the black square. All right, so I've done steps 1, 2, and 3. That's all it took. So I've got to find for each value of D, for 0.25 and 0.50, what value of theta, so I'm along the bottom here, what value here will give T, which is here, of 100, and that's here. So I've found out, I've gone through the whole question and found out all the values, and now I just have to join the dots pretty much. So I have to find the white circle when it's 100, and that's 100, the white circle would be here, so that's 30. And now I have to find where the black square is at 100. So 100, the black square is along here, and that's 50, so it's 30 for 0.25, and it's, so that means H and J are out, and then I need 50 for the second one, so it's going to be G. All right, 27, based on figure 2, which I've messed up pretty badly, so I'll rub out that. So based on figure 2, oops, I did not mean to do that. Based on figure 2, and no, it won't come out. Come on, there we go. Based on figure 2, for D equals 0.5 and theta equals 10 degrees, the weight at which T equals 600N would most likely be. All right, so again, figure 2, I think it says that D, hang on, figure 2, yeah, D equals 0.5, so that's fine. So in D equals 0.5 and theta is 10 degrees. So let's find theta, and that's there. So first step was find that, second step, find theta, and then find the weight, and the weight we know is in this key. So find where the white circle, the black square, or the white triangle is at 600N would most likely be. So at 10, and then we need to go to 600, and that's here. So the white circle is between the white circle and the black square. The white circle is 100 and the black square is 200. So it's between 100 and 200, and that is answer choice B. All right, based on table 1, scrunch this up a bit. Based on table 1 and figure 2, so that's our first step, is find those. For D equals 0.5 m and at theta of 10 degrees. So I know figure 2 just deals with the D equals 0.5, so I don't have to worry about that. So theta equals 10 degrees will be 2. Can a 1.5 millimeter diameter stainless steel cable, so I need to find that, support a sign with a weight of 300N without breaking? 4. All right, so I'm going to table 1, so that's right hand side over here, and figure 2 is here. The diameter 0.5 meters and a theta of 10, so it's 10 again. Can the 1.5 millimeter diameter, so I've looked at figure 2, so I need table 1 gives me cable diameter, so 1.5 is 531. So can that support a sign with a weight of 300N? So we look here and we see that 300N is the white triangle. Let me increase that a little bit. And the white triangle is way up here, so its tension is 1000. So I'm going to have to read, I think, a wee bit of this description here to find out when that is true. So let me see. The sign's weight W, the angle theta, is between the cable, is the angle between the cable and the rod, and the distance D between the center line and the sign and the wall will each affect the tension T, and the cable will break. Oh, here we go. The cable will break if T, tension, exceeds the cable's breaking force F. All right, so the cable diameter F is here. In table 1, this is F, and we see it's 531. And then the tension is, we looked at that in figure 2, it's 1000. So T is 1000, F is 531. So it says if T is greater than F, the cable will break. So the cable will break because the tension is greater than the F, whatever that is, of the cable diameter. So what's the question? Cable, can it support a sign? So no, it can't, because it's going to break. So we know that F and G are out because they say yes. Now we just have to find the right answer. No, because T will be greater than F. Yes, that's true. It's H.